So welcome everyone. Nathan Ritchie, the Tech Director for Salt in the UK. So regardless of what the slides said or the agenda said, I'm not going to present lots of slides today. It will be an interactive live demo of our solution or product. So hopefully a bit more interactive, a bit more exciting than slides. I will cover our architecture first, and then I'm going to go into the demo essentially, so you can see what we actually do with data, how we use it, how we visualize it, what you can see if you become a customer of Salt, but also just in terms of general information for the market. So Salt is all around context, it's all around correlation of information, both from a discovery and attack detection perspective. So the thing that we need, first of all, to do what we do, and the thing that all customers start with, is discovery. So collection of your APIs, and then pushing them into our service so we can analyze them. And we do that in a number of different ways. So we do what we call plugging in or collecting traffic. And we can do that by plugging into anything from edge gateways, load balancers, proxies, native cloud environments, API gateways, API management platforms, you name it, we have a plugin for it, essentially. And I'll cover it in more detail in a minute in the next slide. And then what do we do with that data? We put it into a big data engine. Now, we've been doing this for 6 years, so we have ML and AI trained algorithms that have seen hundreds of billions of requests over that period of time, lots of different types of data from different types of customers. And it means we have lots and lots of compute power, so we can crunch data in near real time, up to a year ago in terms of traffic that's stored, comparing that and contrasting it to what we see now. And we use behavior analytics. We apply hundreds to 1,000 or so data points to every request that comes in, every response that goes back out. So we can look at behavioral traits, behavior analytics, correlation of what the behavior of the user is doing. So we can really understand, the context of what an attacker is doing and how they're attacking you. If you have any questions, by the way, just raise your hand and we'll go. And then, we have a pattern around how we do this. We're the only one in the industry to have a patented approach to, API security. You can see the pattern here, and we'll advertise that later in the slides. And we push this into 3 key pillars of capability, essentially. So the first is discovery. So once we plug into your environment, everything is automatic. There are no rules, no configuration, no policies, no signatures. We simply learn everything from scratch. So we learn every API that our customers have from scratch. We learn them over a period of time, and then we baseline that normal usage pattern, and then we can start to look for anomalous behavior against that normal usage pattern. Now, with that auto-discovery, so all your APIs, the endpoints that map those APIs, and anywhere you expose sensitive data in request to response, we map automatically and continuously. So any change in your environment, we pick up automatically and alert and flag that to you. That's the first pillar, discovery. Then it's the attack detection and prevention. So I've kind of talked about the detection. I will show some of the attacks in the UI in a minute. And prevention is a bit like the reverse of detection. So anything that we can read traffic from, we can talk back to block an attacker. So we can block an attacker at your firewall, your load balancer, your proxy, your gateway, whatever existing device or WAF even that you have, for example. And then lastly, closing the loop, remediation. So here's where we're going to sort of shift left. Here's where we're going to help you look for misconfigurations, which is a lot of way APIs are breached, unfortunately, now. Also start to shift left and look at how you better document and design your APIs, so comparing them to OES spec, for example, and looking at drift analysis between what you've got and what you think you have in real environments. So that's the kind of how we do what we do in the background. Let's talk a bit about the detail. So if you focus your eyes on the API collections box in the middle, that is a sample of the most commonly used deployment methods for us. There are about 70 ways now we can plug into an environment. The top ones, the agentless options at the top of the box, they're all policy-based. So you upload a custom policy and you enable that policy over your chosen scope of APIs. It takes all about 15 minutes to deploy. So we can deploy into production, UAT, any pre-production, POC environment, whatever, in about 15 minutes for any of those gateway providers. Really is that quick. So we're not on a product that takes months and weeks to deploy. And then the microservice architecture underneath, Docker, Kubernetes, AKS, GKS, OpenShift, whatever you have, we can plug into it with a sensor. A small piece of Salt code that sits in line at the pod, at the controller, as a sidecar, whatever. And then any of the devices at the edge, we have plugins for. There can be native mirroring capabilities. And same with the cloud providers. We can do VPC mirroring, we can do ALB, ELB mirroring, EC2 mirroring. You get the idea. There's 70 plus ways of doing what we do. And all we're doing is taking a copy of the traffic, a mirror, so we don't sit in line. We don't change your network config. We don't add latency. We simply take a copy and then forward it to another destination, i.e. the Salt cloud. Now here's the real key bit about what we do that nobody else does, or not to our level anyway. this hybrid server that we have in the middle, think about that as a cloud connector, and its job is multifaceted. The first thing it does is it passes traffic. So it looks at the traffic, gets rid of attachments, gets rid of images, things that we don't need for API discovery or security, because it's just noise. Then the main job of the hybrid is to desensitize or remove PII data. So we can do this for hundreds of categories of data, anything from credit cards, addresses, IP addresses, names, usernames, passwords, you get the idea. And we use natural language processing and regular expressions trained over 6 years, hundreds of billions of types of requests and response, so we know what a credit card number or an email address in any language or format looks like. And when it picks it up, it will hash the record. So instead of setting the parameter with the entire value of a credit card number, it will tokenize that number. So it just creates a random token and it forwards the token. So we don't ever see you store, process, log, cache the credit card number, ever. It never goes to our cloud. It's kept in your environment. So the hybrid typically runs in your premise as a VM, Kubernetes cluster, whatever you want. So all your PI data is kept in your residency, never leaves your environment. And the hybrid only operates in runtime memory. So it doesn't even log to disk or write to disk or cache or anything. So we really thought about this. And the best thing about the hybrid is it compresses data 20 to 1 and turns it into metadata. So by the time we get it in the cloud, we just see metadata and it's compressed massively. So we don't increase your outbound internet costs either, because other providers do, and they take a raw copy of data and they just increase your costs massively. So that's how we do what we do. And as I said, for blocking, same thing for in, we can do it for out. So anything that you see there, we can use as enforcement points to block an attacker. So we detect a credential stuffing attack or a PI request attack, whatever it might be, we can block them at the firewall, block them at gateway, block them at load balancer, block them at whatever you have that we can talk to. In terms of operationalizing Salt, we can plug into SIMs, ITSMs, alerting, ticketing, etc. So, and a lot of what we do can be consumed via an API, of course. So you don't even need, to use our UI. You can, operationalize us by plugging into tools that you already have. So with that, any questions? And if not, we'll jump into the UI. Maybe hand up or just shout out if you have any questions. If not, then let's proceed. All right. No, that's not sharing. That's not very good at all, is it? Let me see if I can change windows. Oh, come on. Well, that's useless, isn't it, really? Bear with me then. There you go. All right. Sorry about that. Apologies. So this is our UI. Now, this is exactly what a customer has. This is just a tenant, a demo tenant, but it's the same look and feel, same everything that they see. Now, at the top there, you see the number of endpoints and APIs we've detected automatically. So again, there's no configuration, no rules, no policies, nothing else. It happens automatically, and we learn continuously. How many parameters of sensitive data we've picked up? In a real customer, that's going to be hundreds, I'll be honest with you. If you look at someone like a big pharmaceutical company or a bank or a retail, that's way bigger than that number. And how many requests we've seen? That's a tiny number for us per month. Now, you've got a lot of high-level widgets, I'd call them. You can dive into them, so you can sort of hover over them for detail. You can click into any aspect of what we see here. You can really start to get a view of what you're seeing in your environment. It's okay, but I prefer to use the sort of pillar view on the left-hand side to get the detail. But this is quite interesting. Anything that you need, like a call to action box, if you need to look at attacks you're under, this is where you go first. Anything that's changed in the environment, new APIs or endpoints, will be shown here. And one thing the system does, it creates remediation tickets for you automatically based on misconfigurations that we detect. And also pen tests. We use attackers as pen testers. So if you get attacked, and there's a reason that you can close that attack off by changing something in your environment because it's wrongly configured, we create a ticket for you automatically, and then DevSecOps can deal with that process and fix that issue over time. So here's where we differ. I'll start with discovery. So we have 3 levels of discovery. The top level is the API level. We give you a view of the high-level changes, as I said here, about APIs and endpoints, where your traffic is being ingested from. So if you've got, I'm not going to pick on China, unfortunately, here, but I am. But, if traffic's coming in from China and it shouldn't be, or you're not aware of it, and you can see it here, you might want to investigate why. So again, you can see where your traffic's coming from. And then a split of, resource intents and usage for APIs or the most attacked APIs or endpoints that you see here. But the cataloging, the inventory of APIs is more important than you realize when you start this journey, because if you can't correctly map what's an API and what endpoint belongs to the API, how can you then investigate an attack correctly, and which API, and which user, and which data they've attacked? A lot of companies can't do this part correctly. They think everything's an API, and it's not. So if the API contains sensitive data, there'll be a shield icon, like here. This is a payments API, it's external. This is the host, and how many endpoints have been mapped to the APIs. Currently 27. We can auto tag and classify traffic depending on where it comes from. So if you've got a header value that says it's from Azure or AWS or it's production or dev or mobile, or you get the idea, we can auto classify and tag, and that helps for investigation, reporting, classification of data, so on and so forth. You get the idea. But you can also add your own tags. I can add anything I want here. So if it's coming from my Kong or my, MuleSoft, whatever. So I'm going to go into the second view, the endpoint level now. So into the payments API, we've got 27 endpoints here, as you can see, and we've detected back in October 26th, so yeah, today. We split graph separately from REST because it's a completely different query-based language as opposed to typical REST traffic. But this is the endpoint level view. And what you'll notice here, we see all the methods, whether the endpoint is authenticated, so you can do filtering here as well. As you can see, you can just show me the methods or any of the tags, that I was filtering by. You get the idea. But what we do here is use intelligence. When you look at the endpoint level, you can typically have loads and loads of different paths that change at the end of the endpoint. So if it's a database of names, this could be V1 names, Nathan, Mark, Peter, Paul. You get the idea. We don't want to show you hundreds of records for the same endpoint. So we create a variable for you. That's what that squiggly bracket's about. So we've normalized all those noisy results into just the endpoint, because this is the endpoint view after all. And let's go into an endpoint. Let's go into this one here, actually. Here's the difference between us and a WAF and everything else. The real data that we break out. So we've taken the JSON request in this particular example, and we've broken out that complex structure into a nice linear format that's easy to read. And we even break out nested parameters. So this is the request itself, the initial request that we made. It contains a string and a UID. Here's every header and every value. See how many there are. When my mouse decides to keep scrolling. Come on, internet. There you go. There you go. That's just the headers. This is the payload, the content. Even the nested parameters for details account is broken out. And this is where the hybrid's done its job now. Anywhere it's seen or detected sensitive data, it's hashed the record. It's now created a random token, and that means we can track that token across billions of records. So we still don't know what the credit card number is. We do that for every type of sensitive data. So we see everything in and everything out. This is how we can really identify where sensitive data is going across billions and billions of records in near real time. And again, if you want to add, let's say this shipping carrier here is something very custom to your business which you've never seen before, we haven't categorized before, you can now add it to the sensitive data lexicon if you like. Market sensitive data, choose a category, off you go and add it in yourself. So you can tune the engine yourself. Now, it's just as important to do this in request as it is for response, because if you've got data going out in a 400 error response, that is a massive no-no. It shouldn't be going out in a 400 response. So you can see what's going out in your 200, your OK responses. You've got some names and other details going out here. If you've got any data going out in a response in a 400, you can start to investigate why and where. This is a classic data breach scenario. So this is the real detail, but it's not human readable everyday basis. So we create dashboards for you. So sensitive data dashboard is a consolidated view of all that data, what's going in, what's going out, what type of data is it, and then you can investigate from there. So a credit card in a request, pretty normal if you're paying for something. Going back out in a credit card, hopefully you don't want to see that as a business. Which credit card is it? Where is it? Which API and which endpoint was it authenticated? When did it go out? And let's dive into the more detail. So again, you can go back into the inventory view and investigate. So we make it easy for you to filter, easy for you to just track down certain types of data, really easy for you to track down any endpoint or API and really start to investigate where data is going and why, and then look at that in more detail. And then security insights. This is going to be a posture assessment of your environment, really. So have you got any data being exposed in clear text in a URL, like an auth token, easily cacheable, easily stealable? Have you got data going out without any authentication, which means you've got no idea where it's going to, and neither do we. So you've got 12 account numbers going out here to who knows who. Massive security risk. JOT tokens, they live forever in some cases if you don't set an expiry time, which is also a massive security problem, so make sure that you do. But again, you can't retire these because there's no server-side component to JOT. So if you don't set these at the time of creation, you've got no chance of retiring them. So we start to track where they're available in the network and show you where you're exposed. And then things like zombie endpoints and zombie APIs, we can do it for both. This is where you've got an endpoint or an API which you can still connect to, it's still reachable, but it's no longer carrying load. So you're probably not tracking it or logging it, or you don't even know it's there. So again, that's a massive exposure risk to you. It's a bit like the Optus breach, actually, that happened a few weeks ago. That was a test API that was unknowingly exposed to public internet, wasn't being used anymore. With Salt, they would have found that. We would have alerted it to them. So you get the idea about where that risk can be. I'll do a bit of shift left here very quickly. OES analysis allows us and you to analyse your documented spec for APIs and compare and contrast that to how that API runs in a live environment. So you can do that drift analysis. So here you'd upload your OS files, you do hundreds at a time, and you can choose to run a drift analysis or not. And you get a static, like a SAST, and DAST view, essentially. Static's going to give you things like security issues. So are you allowing any type of data to come back in a response field instead of mandating it should be a string, or it should be an integer, or it should be hexadecimal, or whatever? You shouldn't allow this, by the way, in your security design. And for a runtime or drift analysis, have you got any endpoints in your documentation that are not there, but we see them in the API in a live environment? So again, we've compared and contrasted the console API at the top right there with your documented spec for the API, and we found 5 endpoints, and 2 of them carry sensitive data. So again, you're exposing data which you're not even aware of because it's not designed to be there, but it's there. Same thing with documented endpoints, sensitive data in that documented endpoints. So you've got 14 parameters here. I can't scroll anymore. 14 parameters that aren't designed to be there or documented to be there, but they're there. And many of them contain sensitive data. You get the idea. And even if you've got parameters, is there a discrepancy? So we see it's an integer, you've designed it as a string. So again, you've got the wrong type of data going in and out. So this is just helping you to educate you, and you can fix, these issues in DevSecOps, you can put this into a pipeline, you can run this tooling from an API programmatically, so you don't have to use the UI either. So this can be part of your CI/CD, your DevSecOps process as well. And very quickly, I'm going to stay on that shift left idea. So I talked about in my previous presentation this morning around the sort of SDLC process, and it's good to be able to design APIs, document them, test them before you release them. That's what our contextual testing does. Some call it active testing. Essentially, you create your tests and you choose what you want to test. And ours has intelligence built in. So if you're going to try and do an authentication attack, it will only allow you to do it against an endpoint that uses authentication. So you can't just do tests that aren't valid for certain endpoints, otherwise that'd be crazy. So you can choose your tests you want to do, you can configure some parameters, and then you run them. And this will be run programmatically, by the way, in an API. You wouldn't do it in this UI, but I'm giving you the view of what you actually do behind the scenes. And again, then you get the results back. So you can put this into CI/CD, Jenkins, Azure DevOps, GitHub, GitLab, whatever, and then you get a view of what's wrong, how you fix it. So this can be your gating mechanism to check APIs against the OWASP API top 10 attacks, simulate those attacks, see where you're vulnerable, re-release them, iterate them, test them again, make sure they're approved and tested, and then release them into production. And then, by the way, you've got the best runtime detection in the industry, which is, of course, Salt. So that's discovery. Any questions whatsoever? And that's a lot to take in at once. All right. Go ahead. Let's start there.
Is it just REST and GraphQL APIs?
Yeah, but anything that's related to that. So, SOAP, XML, REST, JSON, whatever format. We don't do gRPC yet. It's on the roadmap. There's not a lot of demand yet for it. But SOAP, anything REST, anything, all the standard stuff, absolutely. We split GraphQL out separately because it's query-based. It's more streaming-based. The data, how you take it, is different to REST. It's more an all-you-can-eat rather versus on-demand, back and forth. So we split it out separately so you can easily categorize it. But gRPC is coming. We've not got a lot of demand for it yet, maybe 1 or 2 customers. And, we're moving more into sort of streaming and caching and event streaming, like Kafka, etc. So we'll get there, but there's no demand for it yet. Not really. Another question somewhere?
So I was just thinking more like the integration part. You don't want how the discovery would look like. So are you going to cover that integration part as well?
Yeah, I'll cover the integration hub at the end, just to show you some of the ways that we can do it. We also have a full knowledge base on here, which covers literally everything that we do and how we do it, and I'll show you that at the end as well. So a lot.
Integration may contain like the gateways integration and also
inbound and outbound.
Like the automation CI/CD.
All the configurations all start over from here. So the integrations hub will have the most commonly used ones, but there's so many we don't publish them all because it just don't need to. A lot of the time we have a consultancy with the customer, we have that call, work out what's the best for them, and then it goes from there. Okay. So let's talk about. Oh, another question.
So,
Go.
you mentioned like on the dashboards, right? You show like how if there is any attack or something like.
I will do.
Will there be any mitigation or something will be part of your process?
Yeah, I'll show the attack detection and mitigation just next, actually. So good question, though. So the question for those online was around how do we mitigate attacks when we detect them. So let's cover that now.
So just a quick question. How long is the discovery training process?
How long is the discovery training process? Great question. Depends on the volume or throughput of the API. If your API is heavily used, it can take anything from 2 to 4 to 12 to 24 hours. Really does depend. If it's an API that's used once a day, or once a week. It's going to take a bit longer to establish a normal usage pattern for the API, but that doesn't mean you're not protected. The great thing about cloud is it's a bit like, you know, when you sort of use the benefit of everybody else's learning and behaviour and apply that to new customers. So everything we've ever seen before in that 6-year period, every attack we've ever detected, every behavioural type we've already picked up and trained in our ML, which is over a long, mature period of time now, is instantly applied to every customer and API when it comes on board.
So in a dev environment where it's erratic,
We'll still see it, yeah. We'll still test for it, we'll still see it in the dev environment. It just means you might want to decipher and maybe ignore certain things. So when you come to test and look at attacks and APIs, you can ignore them. So you can set them to ignored. So you might just ignore them for a period of time if you're doing pen testing or you're testing APIs. You don't want to have noise added to the platform. So you can filter it out yourself, is the answer to that.
and just one final follow-up. Do you need to ever retrain?
No, it continuously learns. So it's constantly looking for change, constantly looking for behavioural changes. You know, this is a mature ML model we use for over 6 years now, over hundreds of billions. Our largest customer has 160 billion requests a month for us, big retail. That's their, you know, sort of Black Friday, you know, Cyber Monday, Christmas time. They're about 60 billion a month average. They're absolutely huge. I think I can talk about them. Zoom are also a customer, so another massive customer for us. So, you had a question?
I guess you don't have any chance in discovering APIs, like shadow APIs that are not passing through an
We-
API or API gate.
We do, yeah. Shadow API, shadow endpoints, all included, yeah. So, well, anything we connect to is a collector. We can see everything that goes through it. So if we connect to a gateway or a load balancer or a firewall, you can also ingest PCAPs, log file uploads.
As long as it passes a gate.
As long as it passes something that we can talk to
But if someone deployed an app service in Azure
without telling anybody.
Not telling anyone.
It depends. If we're connected to the VPC that's in Azure, yes, we'll detect it, absolutely. It just depends at what level. If it's specifically going for a gateway, and we're only connected to that one gateway, which is very rare for Salt, we have lots of connection points, normally, or collection points, then there's a chance we'll miss it. But if we're mirroring the entire VPC, there's no way we miss it, because everything that changes we monitor and see. So it's a very rare use case. There's always an outlier. But what we don't do is crawl the public internet for APIs and endpoints, because where's the value? Really, that's not your estate. You don't own that API. You want to risk when it comes into your estate, generally. So let's talk about. Oh, one more question. Sorry.
So let's say we have a multi-cloud API.
Yep,
So
yep.
AWS or
Yeah, it's fine.
So how can we integrate to a single like window where we can say everything, or it will be
You can choose whatever you want. We have integrations into every native cloud provider. AWS, for example, we can do VPC mirroring. We use CloudFormation, Terraform, automation everywhere. A lot of it's self-serve actually now. So what you'll do, if you tagged your load balancers with a value, so it's prod or dev or whatever, we just search for those tagged ALBs and set them to mirror automatically. And anytime you add a new load balancer with that tag on it, we mirror it automatically. So if your environment keeps changing, we keep mirroring automatically. So we've been doing this for a long time. So we're very advanced and mature in terms of the deployment, the management, the processes that, unfortunately some of the others, no offense to them, just won't have yet. We've been doing this for a while now, so maturity counts in some of this stuff, especially ML and AI. So let's talk about attacks. So we have the noise in the tracking tab. This is all the stuff that some vendors hide, the black box of how the magic AI and ML works. We don't, we put everything in there. So this is the suspicious behavior. So this number in production would be tens of thousands, generally, massive number. Noise, a lot of noise. This is all the stuff that's just noise. But this just means it's a single change, or it's a single suspicious behavior change. It's not malicious, it's not correlated, they're not multiple points of behavior changes, it's just one thing that's changed. So we track it, we track everything, but until it becomes something that we need to track and alert you to and deal with, it doesn't appear in the action required queue. So this is where we filter out all the noise. And what we don't do is monitor and then alert on every single possible suspicious change in behavior, because then we just get alert fatigue and you'd never use our system, be unusable. So that's what we don't do. So again, it's intelligence, it's correlation here. So when we get an attack, so this is, and what we do, we fingerprint down to a single identifier. So we fingerprint down to a user ID, a device ID, an IP. This is even a claim from within a token. And we can then track that same ID across billions of records up to a year of data. So like I said earlier in my presentation, a WAF does 5 minutes of data. We can do data over any period, over billions of records back to a year ago, and compare what we see now versus what we saw then. So this attack here, this user ID, it's across the payments API. It's coming from Azure, so we know where to focus our time. 21 attempts. Last 15 hours ago, more than 8 different types of attack from this one attacker, and let's dive into it. So we can see where the attacker's spending their time. So are they in your endpoints? Are they trying to get payments API? They're in a customer ID database, as you can see here, most of the time. How are your servers responding? This is the scary bit. So 11 times out of 20, the attacker's got the data they wanted out as a 200. Straight through the WAF, straight through your gateway, straight through existing security products. Come to us. We detected it, nobody else has. And I'll show you why in a minute. What kind of attacks are you under? So all the API top 10, the obvious stuff that hopefully most people can pick up, but stuff they can't. Parameter tampering. This is how they map out your infrastructure. So if I tamper a parameter and see what comes back, maybe I'll get back your server version. Maybe I'll get back using an Nginx proxy or Apache or whatever. Then if I know that about your environment, I then know how to attack you and what's vulnerable in your environment. I can then map out your infrastructure. Or is it going to be abnormal response? Let's load up a post and see what happens. And then from that, I can then, so this is the sort of small reconnaissance-based changes, the low and slow attacks. It's one piece of change at a time. Manipulate this, try this, attack this, build a picture, get that visibility, and then off we go and try and do a larger attack. This is how they get in. So we pick up everything. And Log4j, Log4Shell, they would have started as abnormal responses to us before they became known as Log4j, Log4Shell. So we pick things up from day zero. Sorry about the mic. And then, because we can fingerprint and tie the activity to any identifier across billions of records, we don't care where they come from as an IP. Because what you don't want to do is start blocking IPs because it's an arms race. They change their IP, we have to block another. You get the idea. If you can just block the user and everything related to their user, block the attacker, not the attacks. And again, ML, AI makes this possible. You couldn't do this in a VM. Just can't. And then the timeline, what is the attacker doing? So you can filter bound to attack types. I just want to focus on bowlers. I just want to focus on parameter tampering, whatever. Just focus on this one endpoint. So I want to investigate an attack from a bowler for this endpoint for this period of time. You get the idea. This is the timeline. So today I'm getting 50% of attacks of normal response. And got a single bowler here. There's some different types of attacks, parameter tampering, etc. here. So you can filter and change, let's just look for bowlers. You get the idea. Everything changes, all right? And then the timeline of what the attacker's doing and how they're doing it. And this was some of the stuff I was going to show in the slides. I wanted to be a bit more interactive, really. This is a single ID bowler. And what we do, we highlight in purple what the attacker is manipulating so that you can educate yourself and we can make it easy for you to understand what's happening in your environment, how they're attacking you. So here, this value has changed 52 times in the last minute. That is a 1,700% increase in the behavior for how often that is normally accessed from this particular user. And we've got the IP reputation details, and that includes things like impossible travel. So if they accessed it from the UK with this IP address and then 5 minutes later they're in the US with a different IP, there's no way they've travelled from the UK to US in 5 minutes, so they're proxy hopping or VPNs or whatever. And then how are your servers responding? So the reason this gets through a WAF is because this looks completely normal. There's nothing wrong with that. It's not misstructured, it's not malformed. It's just that 52 character number there is manipulated, it's changing over time. So if you have to track that one number that's 52 characters long that changes every 50,000th record, every 10 records, every second or whatever, you couldn't do that without loads and loads of compute power. The ability to do this and track it down to an identifier and pin that identifier over time. The benefit of ML and cloud versus, you get the idea. There's a picture I'm painting for you here, but you get the idea. And then we've got things like double bowlers, where they're manipulating two pieces of data here. So they're changing a cookie ID and auth ID, and this is, there's 200 response here, so that means the attacker's got the data out they wanted. And let's break it down. So we would decode the auth token. So this is the JOT token decoded. So we can now see who they are, what they're breaking out into, if they're going to hide or mask their originating user ID, what they've stolen up here, and there you go, you're mapping out infrastructure to them. So again, they can then start to learn your estate, learn your infrastructure here, okay? So we break down double bowlers, also things like rate limiting. So not just data limiting, rate limiting, but also PI-based limiting. So if they're accessing a certain type of data more often than usual, we'll pick that up so you can start to see where and why and how often. Question?
Would you identify if they try to do price harvesting, that's looping through
Absolutely.
the API with different parameters to get the whole tariff?
Yeah, it could do. Yeah, it's just another parameter, isn't it? If they start to try and harvest or access parameters more often than not, and it's a certain type of parameter, we'd flag it. We won't know it's price harvesting per se because that's not what we're designed to do, but we'll flag that it's still parameter or PI-based access. Absolutely, yeah. The end result of that could be price harvesting. I'll tell you what, we get a lot with these sort of bowler manipulations where they manipulate one value, and they're trying to. A bowler basically means I'm trying to steal somebody else's data by manipulating an account ID or a user ID, or in many of the retail sort of environments I work in, a shopping cart ID. So I've now changed the shopping cart ID, put some random numbers in, I've got somebody else's shopping cart back out. So you need to know what they're buying, what their address is, where it's being delivered to, how they paid, You get the idea. It's really easy to do this. You know, if it's a bit like going to a nightclub, putting your coat in, getting a ticket, change the ticket number, getting someone else a ticket on the way back out because it's a bit nicer. It's the same kind of thing, right? It's the same thing but with data, all right? So broken auth, we see a lot of this where they're missing authentication header, and again, you're not mandating in your security configuration that the header has to be present because it's missing, it's been removed, but you still give them the data out. So there's all these things that you probably don't even realise that are misconfigured in your environment that we pick up and nobody else will. Jot token manipulation. We see this a lot where they're just manipulating or breaking, or luckily you got a 500 error response this time, so your servers and your backend has picked this up. But it's just parameter tampering. So again, what's going on, how to fix it, jot manipulation when they're trying to elevate their role to an admin, for example. Again, they've got the data out from you. And again, this is what they're doing. They're trying to manipulate this. So jot manipulation, authentication manipulation, header manipulation, parameter tampering, rate limiting, OWASP API top 10, we pick up pretty much everything because we're very good at what we do, and this is very accurate. Our false positive rate is very, very low indeed. And then what do you do with it, to answer your question earlier about how do you then remediate, how do you then take action? So this can be automated, and essentially you set up your outbound integration. So this is just what I've set up. I want to block up my WAF, I want to block up my firewall block. You could set up any number of integrations for load balancers, firewalls, proxies, API gateways. You get the idea. So I'm going to block at a WAF, only IP-based for a WAF, or this one. But I might block it in Perva, or a firewall. I can do user blocking. So I'm just block everything related to that user now. So everything to that fingerprint, everything attached to that ID, block. So all those IPs are attached to it, block. And this can all be automated. So it's entirely up to you. You trust it to do it, automate it in the end, but you'll start with manual blocking, probably learn the system, figure out what you want to integrate into, and then you'll automate all this over time. One of our customers in the UK is I'm not sure if I can say or not, but they're AWS based completely. They get thousands of credential stuffing attacks every week, and they're all AWS based. So what we do is when we get an attack or a credential stuffing attack we detect, we then create an AWS Lambda function for them, which then stops that attacker at the AWS API gateway. So it's completely automated. So detect, block, Can they keep changing their IPs, keep changing their user IDs, detect new one, block a new one. It's an arms race round and round and round and round, but it's all automated. So it's very easy for us. So that's attackers. And then where you see these remediation events, this is where I mentioned we use the attackers as pen testers. So here, there's a weakness that can be remediated in configuration or design, misconfiguration essentially, and then we put it into a remediation queue. And we also do that for everything else we detect. So in the remediation queue, you'll see the high, medium, and low. So the really scary stuff you want to fix urgently, less scary, etc. You get the idea. And here we're going to tell you what to fix, how to fix it, where to fix it, as easy as possible. And again, this goes into Jira, Zendesk, all automated again. So what API, top left here, which endpoint, what's wrong, this is what's there now, this is what you should have. So again, we're doing this against OAS spec, we're doing this against design standards essentially. We're doing it so we know that there should be, you should lock down whether it's a certain, value or length or characters, for example. You should, if you're having an array of letters, it should be restricted, for example. So these are best practices. This is OAS 3.1, I think the latest spec is, design guidelines. So this is what the misconfigurations you're going to get it against. And if you're doing this in a ticketing system, so again, you automate it to Jira. It'll create a Jira ticket automatically. Please fix urgently. You get the idea. Can never type when I'm being watched. Don't know why. You create that in Jira. It uses a 2 API. You then go and close it off in Jira. It comes back in our system, closes it off, and it'll come into the resolved queue in here. And again, you can make comments. You can filter. You can do what you want. So that's remediation. Anything that we're plugged into, we collect traffic from. So our hybrid server mentioned, we got a health status. So these are hybrids that are connected. These are all the collectors and how healthy they are when they're last connected. So we monitor environment for you, so you don't have to monitor it yourself. We can even upgrade and manage these things for you remotely, if you like. And then finally, to your questions earlier about Integration Hub, and I'm going to finish very shortly. This is some of the inbound integrations. I noticed Gravity were here earlier today in downstairs. We've got another Gravity collector now. So these are things we can collect traffic from, and this is more self-service. So EKS deploy, there's a VPC mirroring deploy, there's Apigee, there's Kinesis Firehose, there's automated mirroring. This is going to be the tagging I mentioned. So it's basically, how we do it, the YAML files we use or create, and how you do it. There's the actual YAML files. There's the token for each customer, for each auth. Off you go, do it yourself. So these are the most commonly used ones. There's not everything in there because there's just too many. And outbound is going to be things you want to talk back to. So you want to talk back to my SIEM, my ITSM, my ticketing, my logging. And we can even do custom webhooks. So a lot of customers use Splunk, but they do it in a custom way. So we can build a custom webhook from the UI. It takes a few minutes. You choose what kind of event it's going to be. It's going to be an attack event, a remediation event, an audit event, what's happened in the system, everything. It's going to be a post, generally, and you give us an XML template or JSON template, and then we use variables for what gets spat out to it. So It's really easy to create any integration if we don't have one out of the box, but there's also loads of stuff in here that you can add, and we add more and more all the time. And then CI/CD, I want to integrate into GitHub, GitLab, Jenkins, Azure DevOps, whatever. This is when you start to put in your CI/CD integration, then we can automate the OAS testing, we can automate the contextual testing, the pre-production testing. So you can do it all automatically in a nice, slick, easy way of doing it. And then finally, settings. So this is where you can add us into SSO. So you can SSO into our system. You can use us to block users at an SSO, for example, on outbound. You can get insights daily, weekly, monthly about new discoveries, new security alerts, as well as all the alerting I just showed you from an outbound integration perspective, so over and above Splunk, everything else. You can add and tune sensitive data. So these are the categories everybody gets, the global stuff. These are categories built automatically based on your APIs. So if you're not a car manufacturer, you probably won't have a VIN number category, I hope. And then you can tune it by regular expression. So this is a regular expression builder in a UI. Just pick the categories, pick the ands, the ors, the nots, and off you go, create new regular expressions without knowing regex. So you can tune sensitive data to your liking, as well as exclude and include certain data. And then very, very quickly, everything we do is contained in a knowledge base. So all of the ways that we can ingest data, for example, here. So you get the idea about deployment guides. So let's say the inbound collection options. So the gateways, there you go. You get the view of why we don't put them all in the console, because there's just too many. All the microservices, it's all the load balancers. you get the idea. There's tons of them. We can do so many different ways of deploying. Excuse me, my browser's hung on me again. But you get the idea, right? There's just tons and tons and tons of them. But to publish them all in a big UI is just going to take loads of space. So good place to stop. Ask for any questions. Go ahead.
How much setup is required?
Yeah.
Get started, so you've got
Great question.
APIs. Do you have to import all the API specifications? So you
No.
compare against them, or is it fairly automated?
No, it's all automated. So we plug in and we learn. So it depends on where the APIs flow through. So typically, an average customer is going to have between 1 and 3 collection points. So anything that's public facing, it's exposed, your sort of north-south traffic, as we call it, like an edge device, load balancer, API management platform, anything where it's aggregated into a point, let's plug in there. So we've got protection and visibility of your public-facing APIs and data, point number one. And then a lot of customers want to do east-west, so at the microservice layer, what's internal, what goes to other systems. So again, we plug into Kubernetes, plug into Docker, plug into whatever you have, a VPC, mirror from there. And then finally, south to north, we're reaching out to third-party providers. So what's being exposed out? So we did a POV, a big pharma company recently. We found 500 outbound connections to Salesforce. And they're asking, why do we have 500? And I have no idea. But you have 500 outbound connections to Salesforce from one company. Nuts, right? So you get the idea. Setup depends. A policy-based deployment, so all the gateways are policy-based deployment, about 15, 20 minutes. Actually, we're targeted to be done within an hour, any environment. AWS VPC mirroring or automated tagging and EC2 mirroring. If it's a big company and there's multi-regions and they've got hundreds of ALBs or thousands in some cases we tag them and then we automate it. And that script might take an hour or 2 hours to run. It's not under our control, it's AWS, it's how long their environment can process it for. We start it off and we leave it, come back in a few hours, it's done. Most of the VPC mirroring is just a few settings in AWS. It depends. Most stuff we can do in an hour, including the hybrid. So for hybrid, again, we've done this over a long period of time. We use what we call a convenience script. Single line of code, you put it into give us a VM, an Ubuntu 2004, or give us a Red Hat or whatever, run a single command line, it does all its pre-flight checks, it pulls its code down, uses Terraform in the background, maybe even uses K3S, and then spins up, does its outbound connectivity checks, takes about 10 minutes, green, done, ready to go. And then you send your traffic from the sensors to the hybrid, or the collectors to the hybrid, and the hybrid to the cloud. You open one port up outbound from the hybrid, so 443, typically one port from every sensor into the hybrid. So 2 ports internally, really simple. We can deploy a big production customer, multi-region globally, week, 2 weeks tops, and that's their system processes, not ours. We can deploy in anything in under an hour, pretty much. And that sounds a bit ridiculous in a big environment, but it's true, we can. So for POVs, POCs, we deploy in about an hour. We agree one collection environment, hybrid yes or no, set a time, book an hour, off we go. We learn for the first week, and at the end of the first week, we then do the review of the sensitive data and discovery. Week 2 is about attack detection. We can do simulation of attacks against your environment to see where you're already vulnerable to OAuth API top 10 attacks. At the end of it, you get a nice big PDF. That's your business case. Take it back to your internal management team. Use all the data we found. Here's your exposed. Here's your sensitive data exposure. Here's your vulnerability risk. Please can I have some money for API security. Thank you very much. That's the idea. Questions? Any more questions? All right, I think then I'm done. So thank you very much for your time. Thank you very much.